Hello everyone, my name is Shravan Kumar Ilapanda and I am a certified enterprise architect with over 17 years of experience in IT. I worked for MNCs like Cisco, Mark, and from last 7 years, I'm running my own startup by overseeing all the business verticals. And I have a mentorship experience by over a decade to train professors, teachers, and students in different domains like cloud computing, design, architecture, DevOps, automation. So wherever I go, a lot of people have been asking, Shravan, why can't you help us on troubleshooting? Because a lot of operational team and even other production team have been struggling on spending a lot of time on troubleshooting production issues. So here I'm very excited to start a troubleshooting masterclass session with a deep knowledge in operational excellence and contributing for people to reduce their time and efforts while troubleshooting their issues. So let's join this troubleshooting masterclass video podcast, which will have multiple parts of it. And today is the one among first session. So I hope these sessions will help you to upskill your troubleshooting skill set. Let's start. Hi all, welcome back for the first session under the Troubleshooting Masterclass video podcast. As I mentioned in this session, we are going to go through what are the techniques, best practices, and what are the other needs to be taken care, and how we are going to handle if any production issue arises. So let's jump into it. I want to make sure you understand the objective of this podcast or this session. I'm expecting at the end of this troubleshooting masterclass session, the participants will be able to confidently diagnose and solve complex problems, especially not only solving, and you should be in a position to communicate effectively with the corresponding stakeholders. And obviously, it is a continuous improvement effort where you're going to learn so many things while you're doing things. So I'm hoping this session will be beneficial for individuals who are responsible for troubleshooting technical issues, as well as who want to improve their critical thinking, problem solving, and communication skills. So don't think this is only a technical troubleshooting session kind of podcast. Rather, it is more focused on a holistic approach, how you're going to handle when something goes wrong. So I'm going to follow an approach which is called TTT. T resembles troubleshooting with a proper technique with proper tools. So all the required techniques and proper tools, we can troubleshoot in a better way. So let's see what are the techniques or what are the tools we are going to follow, or what are the framework or what are the methodologies we are going to follow in this session. Let's have a detail. As I mentioned, troubleshooting is not a kind of a break fix. So there is a lot of people might misunderstand. If I fix the issue has been resolved. Or if I'm applying a workaround, the issue has been resolved. So it is a kind of a break fix. That means if something goes wrong, you are fixing it temporarily, it might arise again. Nobody can guarantee that. So under a proper troubleshooting approach, you need to have holistically end-to-end covered into making sure it is not repetitive. So nobody can confirm or nobody can give 100% guarantee, but that's what we need to achieve for, or we need to goal for it. So first it starts with understanding the approach. As soon as you understand what's the problem. So definitely guys, with my experience, I can see, just imagine if some user is reporting, I'm not able to access a web server, or I'm not able to, access my Linux server, or not able to access my Windows server, or my application is performing very bad. or there is so much of things, or too much of proper mechanism has been there. So what I'm trying to understand is, if somebody comes to me, how I'm going to identify the problem and how I'm going to define it. So basically it is more about a problem statement, identifying the problem statement. How you do that? By looking at the symptoms of the problem and gathering appropriate relevant information, and then you need to come to a certain identity what could be a possible problem statement. So I'm going to explain much deeper how this understanding the problem is little different than looking at an issue to fix that. So this is the first and foremost technique comes on to place while troubleshooting it. Next, it's more about the root cause analysis. People might heard RCA, root cause analysis, at different layers or different places. So it is one of the technique and tools for identifying the root cause of the problem and including the different types of techniques we might use. See, root cause analysis is based on which organization and what is the policies they enforce. So certain organizations use a 5 eyes technique, and some organizations use a fishbone. Some organizations use Pareto charts. So like this, each of the organization might use a different standard for troubleshooting and for especially the root cause analysis technique. So we're going to look at what kind of techniques enterprise uses and what are the best suits for which organization and how we are going to handle and in terms of real issue. We are going to look at in deeper in some time. Next, troubleshooting methodology. One thing we need to understand, guys, people might call it as, okay, while we're doing troubleshooting itself, why we need a technique, why we need a methodology. Let me put it in this way. See, when there is an issue comes up, break fix a certain thing, and then you might have an RCA, then you need to PBI, problem incident will be raised. For that, you need to create 5 eyes RCA or any other model which you look at. So the troubleshooting methodology is a combination of structural approach where you have been including the problem statement and gathering data and the isolating problem by testing with a hypothesis condition and implementing the solution. So this is a holistic approach to permanently fix the issue. So that's why this is a methodology, how we are going to handle a certain kind of issues. Then there is a technical skills, and people or you might ask, okay, if I have a technical skills, that should be fair enough, or is it sufficient? So definitely from looking at the technical standpoint, that might be sufficient, but just imagine if you want to communicate back to the current stakeholder, which is taking more time to fix, or to find out what would be the proper impact of your issue, if you have been not able to understand or articulate the impact corresponding back to the appropriate stakeholders, then it will be a different sign of the issue. It will impact in other way for you. So that's why along with the technical skills, you do need some other skills which I'm going to talk. But obviously, in most of the times, here technical doesn't not necessarily be Linux or Windows or DevOps or certain thing. In any field, if you're talking about a machinery, you need to have a machinery technical skill set. Or if you're talking about any other domain specific, you might need a technical skill set of that specific domain. So this one is one of the mandatory technical skill. In this technical skills, we are going to look at, from whether it is industry specific or whether it's technical specific, and how we are going to troubleshoot, whether it's a hardware issue or, mechanical issue or a network issue. There are so many ways based on the skill set. Correspondingly, you can resolve the corresponding issues and then come up a problem solving technique. So this is also one of the technique which we use follow a creative problem approach. What does that mean is, if any issue comes up, how creatively you can resolve that by brainstorming it, or if you have been asking for a help from the peers or your colleagues, what could be best approach, and lateral thinking and a forward analysis. There are so many other problem solving techniques have been available in the in an enterprise where you can choose or pick what best suits for us. And then communication skills, as I was mentioning just before that, communication skills plays a vital role. It's really important for us to understand how these things works in a matter of time. And if you are not properly or appropriately communicate with your stakeholders at right time, then it impacts a lot. Trust me. Because even though you know how to fix it, but if you are not able to articulate the same thing, to your management or appropriate stakeholders, it won't much make difference whether the server is or an application or something is down or have an issue. So communication skills is also have one of the technique for most effective way to get full communication back to your stakeholders, including active listening or effective questioning and clear and concise reporting. So this all comes under the communication skills. So each one of this is a pillar for your constructive troubleshooting techniques. So I'm going to go deeper each one of it in a while. Next is time management. So most of us know time plays a vital role in any situation, especially in the troubleshooting. It plays even vital role because let's say that if server is down, if you don't know when it is down, or if you don't know what is the impact of when it has been down, or if you don't know how long the server can be down, so these are all things comes under the time. So here, time management, you need to really tick box while doing prioritizing the issue. To give a simple example, let's say that if you have 3 issues come across at the same time, so if you are not able to prioritize in a proper time comes into place, that's also a time management. So time management plays a very vital role. How you have been handling the situations, that really tells how you have been handling when some or more issues arises at the same time. Next, I'm going to cover about the best practices. So best practices is a combination or mix or match of kind of methodologies or techniques or skills. This all comes under the best practices, which I'm going to talk or I give a summary kind of what you can take out of it. Then it is a continuous improvement. Any one of the stage, if you look at, all the stages needs a continuous improvement. That means if one thing works for you for one troubleshooting issue, then it doesn't mean that it's going to work for everywhere or for every issue. That's why it's a continuous improvement by your experience, learning experience. By doing it, you will definitely improve that much effort. So how you're going to do that, that's also we're going to talk in detail. So now let's start with understanding the problem. So this is the foremost important thing for us, how you're going to handle when something arises. What does it mean? When understanding the problem comes up, first thing you need to know what is the problem. But with my experience team, when I joined any escalation call or when I join any call with the team, when there is some issues there, most of the times I end up not listening what is the actual issue. People will talk about what has been happened, what they know about it. But until you clearly scope of the troubleshooting session, it's not going to benefit us. So that's why you really need to define the problem very clearly, very precisely, and be specific to what you've been talking about. And by doing that, you can start with it to identify what is causing the issue. So identification plays a very vital role. And by doing that, you need to identify what is not working and what is causing the issue. You have to be very precise and specific. So how you do that? You can do that. So, you can ask me a question. Okay, Shravan, so when I'm doing the troubleshooting, a lot of people are not able to share that information. That's okay, because not everyone is technical or not everyone can understand the system. So, but where you can start with this, you need to start with gathering relevant information. So these are all a combination. If you look at here, one to other, from define to problem to gather relevant information and identifying the impact, analyze the problem, all this, if you look at the right side, these are independent or dependent to one another. So based on the situation or state, sometimes it might act as independent things, but in most of the cases, these are all act as dependent to one each other. So gather relevant information. What it meant, you need to collect as much as information when you're starting troubleshooting the issue. So what could be like that? This could be including symptoms, error messages, logs, and other data that might help us to diagnose the issue or at least to start the troubleshooting the issue. So you need not to leave anything. You should have all the information as much as you can. You have to collect the information. That's the most important thing which I can think of. Because if you delay that, later on the postures will be different. What happens, after an hour or a two, then if multiple teams are involved in the troubleshooting, then ball will be thrown into different courts because you don't have the exact information. So when you can get the exact information, as soon as you get involved or as soon as the issue arises, you need to start collecting the information. That's where you have a primary evidences of what has been happened. Next, identify the impact. So this is also the foremost thing to do, because a lot of people in operations especially, they are in a hurry to fix the issue without knowing the impact. So I totally agree with the situation, because the team has to work on to resolve the issue as soon as possible. But at the same time, you need to capture the impact, because once the issue has been resolved, you really cannot go back and see what has been getting impacted. And why this is impact analysis is most important, because as part of your RCA document or as part of your documentation to resolving the issue, you need to track, because in future, if something arises, what could be possible impact and what is the business impact? There's a lot of impact. It need not to be a business, but it can be a system failure, an application failure, or a dependency of so many other things comes into place. So that's why you need to identify the impact, really understand the impact of the problem on all the systems or users or customers and stakeholders at a different layer, how it is impacting it. That will help you to prioritize the problem and determine the urgency of the fix. Because you cannot take everything as a P1 or you cannot treat everything as a P6. You have to really balance between P1 to P6, but based on the business impact. If you look at in most of the cases, these priorities are being defined based on the impact. So really you need to understand the importance of the impact, and based on that you need to adjust the priorities. As I was mentioning earlier, the prioritization comes to the time, and that will come under here. Identify the impact will by propositional to the time management. And then definitely you need to analyze the problem. What is meant is, this is kind of an agile think of it. When a bigger activity comes into it, you are going to break that into smaller peaks or smaller chunks, which will help you to focus and which will help you to distribute, which will help you to troubleshoot in a modular way. That's exactly analyze the problem will help. So by doing that, you're going to analyze each component to identify the possible cause. Let's say that if you have been doing the problem, a compute, a storage, or network, or database. In a machinery, the primary or front end or back end and any dependencies. So like this, you need to really look at and break down what are the smallest part of the contributor for this issue. Then ask questions. This is another important stuff. You might have asked the questions while gathering the relevant information. So gathering the information will put you under the spot in such a way. What is the preliminary information you can collect it? It will also have certain limitations. So you are getting all the answers by itself by gathering the information. That's very good. But in most of the cases, what happens is, until you have the proper question in place, you might not get the relevance information. So that's why you need to really ask questions. Like, for an example, when did the problem start? And what actions were taken before the problem occurred? So from the environment side, anything has been changed. Or if somebody has manually did something, or if some script has been run after that in the issue, or some deployment happens after the issue has been arised, or before. Like this, you need to ask these questions, relevant questions that will give you the appropriate answers to go into the right direction. That's why ask questions will really help you how you're going to handle that. Then verify the problem. Verify the problem because somebody has reported it, but it's really been happening in the way what has been reported. We might not know, not all the cases, but as soon as possible or when as is possible, I would really encourage to reproduce and to the issue so that it will be more consistent when you're determining the problem or isolating the issue with the semantic. So verify the problem is also going to help you to make more possibly isolating the issue while you're doing it. That's the very one of the best approach I would say. I'm not saying all the time you get the possibilities to verify the problem on your own, but it's all depend because your concluded goal, because by the time you might have a short fix or workaround, but in a longer run to non-repeat the issue, how you're going to handle, that's why the verifying problem in a separate environment really will help you. Then consider the context. So this is also an important segment, guys, because in my past experiences, when I joined the call as a manager or a lead or to as a consultant or as some XYZ position, the people will talk about in their own language. Excuse me, in their own language. So start understanding the context of the problem in terms of including the system architecture, configuration, environment. This will really helpful to identify the potential root cause and determine the scope of the problem. So when people are been not talking in and around, what does it mean is if you're talking with DBA, they will talk only from the DBA standpoint. If you're talking with Linux OS guy, they'll talk might be from the Linux OS standpoint. If you're talking with application, they might talk with an application standpoint. And they might have a dependency on different segments. So really understand where this has been happening. So based on the context of what the discussion is going on, you really need to put an efforts and include the appropriate approach during the including the components of like an architecture, configuration, management, and environment kind of stuff. That will give you a proper direction to empass how you're going to troubleshoot your issue. Now let's start about the root cause analysis. So this is one of the very important, I would say a technique which will really helpful for troubleshooting your issue, especially for long-term fixes. You might heard RCA, STF, LTF. RCA root cause analysis, STF short-term fix, LTF long-term fix. So for a long-term fixes, RCA technique is going to help you a lot. So what is an RCA? It is a problem-solving methodology or technique to identify the underlying causes of the problems or an incident. So if a problem or incident happens, why it has happened and how it has happened, RCA is going to help you by using its methodology or a technique. So in this also you have a very important things like define the problem, gather data is very important because that is part of already the understanding the problem, but it's carry forwards in RCA because it is all about when you are entering it. Let me tell you guys, during the issue, it might fixed by operations team, but to find the RCA, people might involve the escalation team. So that means when you are been getting involved into the issue, the actual issue was not exist. That's been already been fixed by someone by implementing a short-term or long-term fix. But you are involved here in a root cause analysis. So that's why from here, you have to define the problem. You have to gather information again to getting forward with the RCA. That's why along with define the problem and gather data, next you need to have identify contributing factors. This is a very, very important, guys, because people have a silo approaches. Now at least people have been talking about DevOps, DevSecOps, kind of a combination of roles. But in past, or even in some certain enterprises today, they still work as silo modes. That is the biggest challenge because you really cannot scale in such a way or to identify what are the underlying problems cause this an issue. So that's why you need to really identify the contributing factors. Once you have all the data, identify the contributing factors that led to the problem. This might include like an equipment failures or human errors or other factors that played a role in what has been issue has been arised. So you really need to go in detailing of underlying architecture, underlying key components, and understand what has been happened. Let me give you one of the example. In one of the organization, people are reporting their ELK stack is not performing well. So now, when they reported, it is being handled by ELK team because that's what they handle the issues. So when they're looking at it from ELK side, it has been looking very good. The from ELK side or Kibana side or Logstash side or Elasticsearch side and the resource consumption side, everything is looking good from the ELK standpoint. They were not able to figure it out what has been happening. Then when we get into the escalation, then when we joined hands with them as a force to resolve an issue, then we gone down into the underlying components or infrastructure. So when I started investigating, I looked into what are the components are being involved in this ELK. So like this, where the compute is coming from, where the storage is coming from where the network is coming from, and where this has been hosted, whether it is in on-premises or a cloud. If it is an on-premises, how it is being allocated the resources, whether any tiering has been implemented, and whether really underlying infrastructure has been having any issues or it has been running fine. So I get deeper, then from my first isolated compute has been looking good, memory CPU is looking good, resource has been assigned and consumption is good, is under thresholds, very well. Next I've been went through network. In network side, I do see network is looking good. There is no latencies between the components, between the nodes. It is under same cluster, so there is not much point from the network standpoint. Then I looked into the storage. Then I figured it out. Storage is coming from VMware vSAN, that is a virtual storage from the VMware. Then they had implemented a tiering system. When they implemented tiering system and when they allocated the storage for ELK, they didn't had a proper tiering in place, which leads there is no proper IO assigned for the disks or in SAN LAN allocated storage. So that's the problem. So that's how we were able to go deeper into the identifying the root cause, understanding and contributors of it. So that's how identifying the contributing factor is more and more important. And then determine the root cause. Obviously, once you go deeper into it, then you need to identify the underlying root cause that led for the different factors. As I mentioned, you need to go really deeper in addressing how it can be preventing similar problems from happening in the future. That's most important for the determinant. Once you have the root cause, you need to plan for your long-term fix. Then you need to have develop corrective actions in place, and you need to document the process, and then you need to implement the appropriate corrective actions. Now, these are all, is part of your game while you're doing the root cause analysis. So that's why, as I mentioned, root cause analysis is really one of the methodology is widely used in terms of an enterprise while they're troubleshooting, larger issues or problems. And within RCA, there is different methodologies we use, as I mentioned. One among is 5 whys. It's more about you need to ask 5 questions, or you need to ask as many questions until you find the answer. So let's see that how that is going to help us. And as I mentioned, the troubleshooting methodology is going to take over of it. Why these methodologies are important. A lot of us might be involved in reactive troubleshooting. What is a reactive troubleshooting? Reactive troubleshooting is the most part of common type of troubleshooting because until you have been engaged or after the issue has been raised, you might be engaged. So if you have a reactive monitoring, then you get involved into the reactive troubleshooting. If you have a proactive monitoring, then you need to involved in the proactive troubleshooting. And you have a parallel troubleshooting, top-down, bottom-up, all these different methodologies have been there. So let's go one at a time. What is reactive troubleshooting? As I mentioned, reactive troubleshooting is the most common, most widely used because most of the enterprises have reactive monitoring. And when problem is been identified and then resolved after it has been occurred. That means once the issue has been raised, then you are going to work on to resolve an issue. So this type of troubleshooting is being widely used. I would say rather than widely, because of the monitoring capabilities what they had, or because of the systems what we have, it might be legacy. Those kind of other contributed factors which leads for your reactive troubleshooting or reactive monitoring. In the situations where your problem is not predictable or preventable, because already issues been happened, how you're going to prevent it? You cannot prevent it. So for such kind of responses, it might be one among them user hardware failures or a user errors. This all comes under the reactive troubleshooting. Then you have a proactive. So as I mentioned, proactive troubleshooting is a very good approach, but not all the times it is possible. Proactive troubleshooting is a preventive approach that aims to identify and address potential problems before they occur. So this is also very good approach, as I mentioned, but it's more depends upon how and where you have been getting involved, or where and how the monitoring system has been implemented. So majority of these problems, in this proactive monitoring, you can avoid it. That means by taking the preventive actions, it will really help. So nowadays, enterprises are looking for this kind of proactive troubleshooting or proactive monitoring mechanisms. Next is parallel troubleshooting. The parallel troubleshooting involves running multiple tests and experiments at the same time to identify the potential issues and the root causes. What does that mean? Let's say that from the storage side, people have been started working from compute side, you are working on other side, network side. So multiple times, multiple things parallelly, you are taking the corrective actions to identify the root cause. So that's why you parallelly, it is really helpful for time to reduce. At the same time, it's difficult to isolate the root cause because multiple times, multiple people have been working. So there is an advantage and disadvantage of parallel troubleshooting. But again, from which situation, which criteria you have been participated with, and which state you have been involved with is also most important in the parallel troubleshooting. Top-down troubleshooting is a high-level approach that starts with symptoms of the problem, and then you're going to downward to identify the root cause. So it is more about listening to the customer or a user who has been reported, then going one at a time in an approach. So this type of troubleshooting is being used in situations where cause of the problem is not immediately apparent. What does that mean is it's been issue has been reported, but not immediately can be resolved or not immediately need not to be attended. Those kind of issues you do a parallel troubleshooting. Then top-down troubleshooting is again my bad, as I mentioned. Top-down troubleshooting is called as where our cause has been not immediately apparent. Next, bottom-up troubleshooting. Bottom-up troubleshooting is the opposite of top-down. It is more about you start from starting with the root cause, then working upwards to identify the symptoms of the problem. This type of troubleshooting is used in situations where the cause of the problem is known, but the symptoms are not immediately apparent. That is, you know the cause, but the symptom might be different based on the time or based on how frequent it's been appearing. Those kind of things you involve or methodology use bottom-up troubleshooting. So these are the different troubleshooting methodologies you can use based on what situations you are with and what stages you have been involved with. Next is technical skills. These technical skills is, I would not always say you know something, you can resolve something kind of stuff. Rather, it is more important how you have been understanding the problem, how you are understanding your ecosystem, or how you are understanding the systems where you've been working with. That's why the important thing is knowledge of the systems. It is more about deep understanding of the systems which are involved in your ecosystem, which are all being a knowledge base. That's why experience comes into place over here. If you want to really know your environment, look into your senior or look into who have been there from quite some time. That's why most of the times experience you have been working in the same organization might help you to understand what things organizations are really using and what service depends on what. And next, familiarity with diagnosis tools. You really need to have tools, how you need to use it, whether it might be a utility, or whether it might be really a big tool, or whether it might be a log analyzer, or whether it be network analyzer, or anything. Based on the situation or technology stack which you're working with, you really need to know and understand how these tools works. And then you need to have skills. in place, like a cloud, hardware, OS, or DB, or network. This is a real pure technical skills based on what skill set you have been with. You really need to have a thumbs up for that. Next, analytical skills. Analytical skills is the ability to analyze the available data and information to identify the patterns. So, in most of the times, also in your organizations or enterprises, the repetitive issues might arise as this. Let's say that in last 3 quarters, how many times specific application had certain issue. If you look at those kind of things, are really helpful to understand based on the data availability for you. You really have certain patterns can come up with. That is analytical skills you can think of it. Then you need to spend time attention into detail. You really cannot leave any stones unturned, because for anything or everything you need to really adhere to the detailing of it. What does that mean is troubleshooting often requires high level attention of detail. Even a small errors or a small log from the small log file or overseas can impact outcome. Like, if you're not looking at if you're not taking care of the minute things, it might impact your outcome, what you have been expecting. So that's why you really need to pay time and really need to have attention of each and every detail when you're working on troubleshooting the issue. Till here, this is the part 1 for your troubleshooting masterclass session, guys. There are so many parts to come up. I'll end up this session and see you in next session. Thank you. Have a great day, guys.